this lesson we're going to look at the chain rule, which is where we kind of use derivatives for a composite function. For our first example, the composite function there, x squared plus 1 is g of x, and f of u is our root u. Is that we can interpret the derivatives as a kind of rate of change. So even just looking at the first example there, we kind of split up the two functions. So it's a link in a way. And you can do this sometimes more than once. You can do it more than once in some questions, or you might use it in combination with the product rule, the quotient rule, or any other rules. But just we're doing grade 11 or AS level now, so that's about as far as you'll go with it. You can also use it in conjunction with other functions, such as your trigonometric functions, exponential, etc., for differentiation. So the first question here, the derivative of the inner function, like x squared plus 1, is 2x. So I'm just going to rearrange the whole thing. So x squared plus 1 in brackets to the power of 1/2 is what that root is. So rearranging that now, we can actually find this a little bit more easily. So put the half out front and then take away 1 from the exponent. That's how we derive it. So you combine these two parts together, as I said, a composite function. So dy over dx is that second part with the first part multiplied together. And you can see that formula in the top right hand side. So that's where we derive this. So it's reasonable to find out the rate of change when we actually start doing applications or optimization and questions like that. So just starting off now, this is kind of simplistic ideas that came about when we had two differentiable functions, and we have dy over dx is equal to dy over du times du over dx. Our second example here, we have the inside part of x cubed plus 1. We just rearrange the whole thing to the power of a half, and of course I just differentiate that there. So the half goes out front, and we take away 1 from the exponent. And then of course, what's that last part? 3x squared. Well, that's the derivative of the inside part. So again, remember, we have an outer function and an inner function for each one. So we put the 3x squared on top, and on our bottom, of course, we'll have 2 times x cubed plus 1 to the power of minus a half, or just rearrange that. So minus an exponent goes underneath. So we have the denominator of 2 times root x cubed plus 1. And that is the whole thing simplified out. Now we'll go into a little bit more based on the trig ideas. Just a little kind of differentiation. Well, just showing the difference between two ideas here. So we've sine, and in brackets we've x squared. So just doing this straight now. So dy over dx. The derivative of sine is cosine. So the inside part, the derivative of x squared, is 2x. So we'll end up with du over dx is 2x, and dy over du is cosine x squared. So cosine x squared times 2x, and of course put your 2x out the front if you want. Just the conventions of writing these things in terms of coefficients, variables, and constants. You'll probably put the constant out front, things like that. Okay, second one now, just to verify that a sine itself, like a trigonometric function, it's not actually a function. In that we don't have a value for it. So sine squared of x is kind of like a shorthand, quick way of doing it. So you need to rearrange that, like the above that you see there. So sine of x and square all of that. And of course, sine x times sine x. You can just put the 2 out front, so you have 2 sine x, and then with the chain rule, which we're doing, the derivative of sine x, which is the inside part, is indeed cosine x. The last part there, we just added it together. It's a double angle formula, which you would have done already. So sine to the 2x. Now moving on to a more complicated example, just for our last question here. So u is equal to x to the power of minus 1 plus x. That's a rearrangement of our inside part. I've rewritten it so that we have the exponent. And y is equal to all of that to the power of 4, which we denote as u. So du over dx, which is the derivative of that first part, and then the same dy over du. I think you should. What did I say? Yeah, dy over du is 4. Just deriving that u to the power of 4 is 4u to the power of 3, and from there, dy over dx. Just put it all together. So you're multiplying this, remember, f times g, as I said at the beginning. And now we want to replace that u, which we know is the inside part. So x to the power of minus 1 plus x inside there. And from there, you can just rearrange it one last time. Just change it back to a fraction. So what you want to do when you're thinking about this is just think about you're evaluating an inner function and then an outer function, and just make sense of that. And you don't need to start doing exponential or trigonometric functions just yet. Just stick to the polynomials for a while and practice them, and that'll get you going with the chain rule. So remember what we're doing here, we're like adding links, and it's a composite function. And if y is a function of u, then u is a function of x, that kind of thing. So rates of change, and even connected rates of change, which we will get to as well in a while.